Today you're going to be working on some doodle notes for scientific notation. Here's what you'll need. Okay, grab a few of your favorite colored pencils and a calculator, and of course make sure you have your doodle note sheet. Okay, let's begin. As we're working through the notes, feel free to color in the digits and make your paper as fun and bright and meaningful to you. Let's start off with these digits, so many digits. So to the left here, this is a very large number, 2,540,000. And then to the right, we have a really tiny number. Like it's not even a penny when I think of it in terms of money. So it is very, very small. So underneath each one, describe it large or huge or giant, and the other one is really small or tiny. So I'm going to call this one a huge number. I would like to have this number in my bank account, and this number over here is a tiny number. And feel free to color that in as you wish. Okay, next we're going to look at this fill in the blank. We need a 4-letter word to fill in here. So we blank the first non-digit 0, and we place a blank blank before the next one. Our first two fill-ins are keep and decimal point. So when we put numbers in scientific notation, we keep the first non-zero digit and we place a decimal point before the next. And we use the powers of a 3-letter word, powers of blank, to correctly represent how we move the decimal point. Can you guess what goes in the 3-letter blank? For scientific notation, we use powers of 10 to correctly represent how we move the decimal point. Okay, so now we're going to take this huge number up here and this tiny number down here, and we're going to put them into scientific notation. Okay, so for our 2,540,000, it said we're going to keep the first non-zero digit and place a decimal point before the next. So that would mean the first non-zero digit is 2, and we're going to place a decimal point before the next one. So our decimal point is going to go right there. Right there. Okay, then we're going to get rid of all of our extra zeros. So this becomes 2.54, and then we use a power of 10, so times 10, and then we have to figure out how many times we move the decimal point. That'll give us our exponent. Okay, so here's how this looks. So we go to the number. Let me change colors so we could see it. Now, originally, the decimal point is invisible. It's at the back. And we've moved it between after the first non-zero digit. So how many positions is that? 1, 2, 3, 4, 5, 6 positions. So our exponent is a 6. So 2.54 times 10 to the 6 is the same number written in scientific notation. So our next one, our really itty-bitty number, we're going to put that into scientific notation. So we're going to put our decimal after the first non-zero digit. That's the 8. So our decimal point will go right there. We're going to move it right to here. And now we look at this right here. This is 8.264. And then our power of 10 times 10. Now we count how many times did we move the decimal. It started here and we moved it 1, 2, 3 positions, and we moved it to the right. So it becomes -3. So our positive exponent right here, our positive exponent was a huge number, and our negative exponents is a tiny number. Like our last chapter, we learned negative exponents become positive fractions, and positive fractions can also be written as decimals or really small numbers. So be very careful. Be careful when you're representing these numbers. Large numbers have positive exponents and small numbers have negative exponents. Moving the decimal point to the left represents dividing by a power of 10. So see if you can fill that in right there, dividing by a power of 10. And moving the decimal point to the right represents multiplying by a power of 10. Okay, so fit that little portion in there, multiplying by a power of 10. All right, let's take a look at the rest of the doodles here. Some notes we have on the subject. When converting a number into scientific notation, and it says, if you move the decimal to the left, you have a positive power of 10, like we just said up here. And if you move the decimal to the right, you have a negative power of 10, like we talked about that -3 up here. Okay, so now we're going to try it in this little box here. Now first, look at this number and think, is this huge or is this tiny? This is a tiny number. So tiny numbers, we're going to move our decimal to the right, which is going to give us a negative exponent. So go ahead and try it on your own and then check it with mine. Our first step is to put the decimal after the first non-zero digit. So that'd be right between the 3's. So it becomes 3.37. And then we do a power of 10 times 10. And we're going to move the decimal, count how many places? 1, 2. 2 places to the right. So we should get -2. So if you tried it without me, did you get it right? Go ahead and turn your page over. Again, feel free to color in other spots on your doodle page as needed. Okay, let's look at powers of 10, and let's really talk about the difference between multiplying and dividing when it comes to powers of 10. So our first example is multiplying by a power of 10. That means we take 8 and multiply by our power of 10, or 8 times 100, we know is going to be 800. So multiplying by a power of 10, we get a larger digit, or we move the decimal to the right. Because originally, the decimal was here, invisible decimal, and by a power of 10 is moving it 2 places to the right. Okay, now dividing by a power of 10, our number is going to get smaller. So we have a power, our digit of 5. The decimal's here. If we divide by 100, we're going to go 2 places this way. And we're going to get 0.05. Make sure you always have the decimal out front when you're dividing by a power of 10. All right, let's multiply again by 1,000. So this is 0.6. And multiplying by 1,000, we would move this 3 places. 1, 2, 3. So this becomes 600. So we multiply, the decimal goes to the right, and we divide, the decimal goes to the left. All right, last one, 0.9, and we're going to be dividing by 1,000, so we're going to go 3 places this way. So that's going to be 0.009. A couple things to put on the arrows right here. Okay, I just made a little note. Multiplying by a negative power of 10 is like dividing by a positive power of 10. And just keep in mind, when you're multiplying, those numbers are getting increasingly bigger. And if you're dividing, your number is going to get smaller. So if you have a negative exponent, your number is going to get smaller. Oh, one more thing. Dividing by 100 is the same as multiplying by what power of 10? So dividing by 100 is the same as multiplying by 10 to the negative second power. Okay, moving on, we're going to do this working backwards section so you can turn your paper sideways. I just kind of had this ready to go over here. All right, here we go. Working backwards. When converting from scientific notation into standard form, those are regular giant numbers or small numbers, remember that the decimal is moving in the opposite direction. So if the power is negative, you will move it to the left. And if the power is positive, then you will move it to the right. Okay, so that's if we undo. When we undo, we use, there's that word again, the inverse operations. We do the opposite operations when working backwards. Okay, let's try a few. Okay, 56,790. So we're going to put this into scientific notation. So we put our decimal between after the first non-digit 0. So that becomes 5.679. We don't need to include the 0. Then we do our power of 10 times 10. Now we count from the invisible decimal to where we moved it. How many positions is that? 1, 2, 3, 4 positions. Big number, positive exponent. Now we're going to work backwards. I see here a negative exponent. Negative exponents become small fractions or small decimals, but they're going to become positive numbers. So here's our decimal, and -2 means 2 powers of 10. We're going to move backwards 2 powers of 10. 1, 2, and fill in with a 0. So what does that look like? So in standard form, it's 0.024. Okay, so again, negative exponent, small number. All right, let's look at our next one. 7,000, we're going to convert this to scientific notation. We put our decimal after the first non-zero digit. So that's just going to be 7. And then we write times 10. And we count from the invisible decimal to where we move the decimal. 1, 2, 3 powers of 10. So our exponent is 3. Moving on, we have, oh, look at this. We have no exponent. So last chapter, when we had no exponent, remember we said we could put a 1 there. So our number is going to get 1 power of 10 bigger. So this becomes 16.5. And our last one, we're putting this really small number into scientific notation. Small numbers should have negative exponents. I remember that. So we're going to move our decimal behind the first non-zero digit. Okay, so that becomes 9.3806 times 10. And this one only requires 1 move. So -1. Make sure you have a negative exponent for small numbers. Oh, and there's one more at the bottom of the page. Putting our last number into standard form, it's going to get 8 powers of 10 bigger. So we're going to move that decimal 8 powers of 10 bigger. So 1469, and then 8 powers of 10. 1, 2, 3, 4, 5, 6, 7, 8. Wow, this is a big number. Fill in with zeros. And then we're going to rewrite that without that squiggle. So let me take a second to erase and rewrite this. Okay, that's a giant number, 146,900,000. Okay, I did have you get the calculator in the beginning, so I wanted you to try one more thing. With the calculator, if you could take a moment and put all of these in the calculator and just double check to see if they are the correct answers in standard form. Remember to put the exponent in, you use that caret key. Remember that button? It looks like that upward arrow. So try those out so we can fluently use that calculator. And then once that's done, feel free to color in any other spots and highlight things and make yours look presentable and pretty for you. Thank you.